at Farm Labs, we're going to build a tiny hydro irrigator to feed this little sprout. We're gonna get the water from here to here without directly pouring it on there. Plants need water to survive, but what if the plant couldn't get to the water? Today at Farm Labs, we're gonna see if we can save this tiny little plant that looks so sad and needs water but can't get any. We have this tiny little sprout. It's sprouted, but it doesn't look too happy. The problem is the soil is dry. I know it's dry by touching it. I'm able to move it around. I can feel it is dry and the plant physically looks sad. It is disappointed and is looking down. Now, the challenge I have is I want the water to get from here to here without picking it up and pouring it. So I'm going to build a system, a pathway for the water to move without me being here. So what I'm gonna do is use this paper towel, fold it, fold it, fold it, fold it, fold it, fold it, fold it. And I'm going to place it in the cup of water and then place it in the soil. I will know I am successful if I can see the water going up the paper towel and making the soil damp. Capillary action is the big fancy science word that teaches us that water can move through tiny spaces, like the space in this paper towel, or in cotton, or when you have a crack, like a crack on the floor. So the water will move from here to here on the tiny spaces. You can already see the green water starting to travel up, the yellow starting to travel up, the red, the blue, and it is slowly going to make its way into the clear one. Our mission is to build a path for the water to travel on. To show you how capillary action works, I set up a little experiment. This is the walking rainbow experiment. Unfortunately, I set it up wrong. But that's okay, because that forces us to think about what we're doing, stop, reevaluate, and then try again. This is what having a growth mindset is all about. We make mistakes, we learn from them, and then we grow. So you want to have as less air in between the cups as possible so that the water can travel more freely. And you also need empty cups. This way you can actually see the water being transferred from one cup to another. And there you have it, it works. Now the question is, will it work for Sprout? Will the water transfer from the reservoir into Sprout's soil? Well, it worked! Now it's your turn. Turn to week 2 of your workbook. Your mission is farmers can't be everywhere at once. Your goal is to build an irrigation system that uses capillary action to pull water from a reservoir up into the soil. If your soil stays damp for 48 hours without you touching it, you've mastered the hack. What you'll need a reservoir, an empty water bottle, soda bottle, cup, anything that can hold water. You'll need a wick, either cotton, a rope, paper towels. Just make sure that it is cotton, whatever it is that you're using. Paper towels work best. The farm. You are going to plant a seed in some soil. Before we can help it to grow, we need to have something to help. That means you need to get a seed, either from a fruit, a vegetable, or the store, and put it into some soil. Ask a grown-up for help. You'll also maybe need some scissors, maybe a marker so that you can mark off exactly where the water is. That way you can measure it 2 days later and see how far it's gone. You'll know you're successful if your wick has transferred water from the water reservoir into the farm or your cup, your pot, wherever the soil is. Once you're ready, you can complete the lab report.